Hello there, my name is Gil Kedar and I wanted to show you a project that my dad and I have been working on for the past 6 months. Ta-da! This is the Bytefrost. It's an 8-bit computer that we've been building by hand out of integrated circuits. It has a whopping 256 bytes of RAM, room for 256 instructions in instruction memory, and a 256 byte stack. Oh, and it has a register file with 4 8-bit registers. Okay, so it's not gonna be running Doom anytime soon, but you'd be surprised what kind of programs you can make with such limited hardware. Right now, in fact, it's recursively inserting a list of numbers into a binary search tree, which it will then traverse to print them out in increasing sorted order. We've also implemented an 8 queens problem solver, which finds all possible ways of placing 8 queens on a chessboard such that none of them threaten each other. In this channel, I'll be explaining the inner workings of a Bytefrost, going from the high-level explanation of a general CPU down to the components that make it up, the challenges we were faced with while designing and building the Bytefrost, and how we solved them. All of the information about the Bytefrost is available on GitHub, so if you ever want to explore or build your own Bytefrost, the documentation is available. The link to the repository is in the description, and if you have any questions, please comment them down below or create an issue on GitHub. Now, we should note from the get-go that even after upgrading the Bytefrost in the future, it will never be able to compete with modern computers. It's not going to run Windows 11, surf the web, or what have you, so why build it? There are a few reasons. First, you get to learn a lot about how computers, including the modern one you're using to watch this video, work, and you get to dabble in almost every level of computer science. As a computer science major studying at UCSD, I was inspired to pursue this project after I saw this chart that depicts the levels of computer science. At the bottom is the physics of computers, i.e. how transistors work and the like, and going up you have the discrete logic layer, and all the way at the top is the application layer, where you write programs in your favorite language. With most projects in computer science, you typically work at one of these layers, maybe thinking a bit about the level below or above you. But with this project, we get to go all the way from the layer of discrete logic circuits, i.e. circuits that work with values of zeros and ones, to the application layer. And it gives you a lot of hands-on experience. In university, when I learned about digital design, we learned about the different components and how they worked, and we designed circuits on paper. We also worked with a language called System Verilog to describe hardware and code. It was a lot of fun, and I learned a lot from those courses, but with this project, I get to take it a step further and apply what I learned by working with real circuits. If this sounds interesting to you, then I hope you'll enjoy future videos and perhaps create your very own 8-bit computer. I'll see you then.